Hey, what's up, SM3? So we are following up on 10.1. Now, we only covered the first part of 10.1 last time. And just as a refresher, in 10.1 we talked about normal distributions. And specifically, we talked a lot about the empirical rule, and we had a lot of problems where we used the empirical rule. The empirical rule stated that for anything that has a normal distribution, we know that a normal distribution is bell-shaped curve, it is symmetrical about the mean, and the area under the curve is 1 or 100% of the area is under the curve. Um, and then we broke that down. The empirical rule helped us found areas, different portions of the curve. Okay, so if you remember, we talked about how within one standard deviation, so this would be one standard deviation away from the mean in both directions, that this composes 68% of the area. And then we talked about how two standard deviations, so this would be two standard deviations, this area here made up 95% of the area, and then there was 3, which was 99.7, and then the rest falls out of that. And so this helped us find probability, and we did a lot of problems with probability. As a refresher of that, if we go to our homework assignment, okay, now we used, in this example right here, we were given that the mean life of a tire was 30,000 kilometers and that a standard deviation was 2,000 kilometers. Okay, so I'm going to use this example here. So if you still have this note sheet down here, we'll continue this. So I'm going to use that same problem. So I know that this is the mean. And the mean in that problem stated that this was 30,000 kilometers. Okay, so we know that the mean was equal to 30,000 kilometers, and it was given to us that one standard deviation was equal to 2,000 kilometers. And a standard deviation is to tell us how much the data is spreading away from the mean, and standard deviation is specifically telling us the average that it's spreading away. So one standard deviation to the right was 2,000 kilometers, which means that this mark right here, which is one standard deviation, was this would end up being 32,000 kilometers. This would be two standard deviations, so this would be 34,000 kilometers, so on and so forth. Okay. Now, we're going to be talking today about standardization and standard normal distribution. So right now you are familiar with a normal distribution. We know what normal distribution is. We went over many examples of normal distribution. Now today's keyword is right here, standard normal distribution. Okay, now in order to find a standard normal distribution, we have to undergo a process of standardization. Okay, and what standardization is it basically takes anything that is normally distributed. Okay, so if we go back to this assignment, these were examples of different products, different sort of data that was normally distributed. However, it's that means that all these had different sorts of distribution. Everything had a different mean, everything had a different standard deviation. Now, what standardization does is it takes that all this information, but from anything that has a standard distribution, what standardization helps us do, it helps us transform normal distributions into something that's consistent, into something that is standardized. So that's what standardization means, okay? Standardization transforms normal distribution into a unifying standard. into a unifying standard. Now, why it's called unifying is that it helps us convert the mean. So a standard curve, a standard distribution, a standard normal distribution has always has a mean equal to 0 and standard deviation equal to 1. So in all these examples that we went through in the time before, all these means, so this one had a mean of 12 days, a standard deviation of 3. This one, of course, was a mean of 30,000, a standard deviation of 2,000, so on and so forth. So what we can do is that we can take these normal distributions, but we can standardize all of them so that they all have a mean of 0 and a standard deviation of 1. Okay? And that's what standardization does. Okay? So how I do that is this right here, this process. Okay? So I know that the distance from here, for the distance from one standard deviation, I'm going to do this in a different color. So I know that the distance from here to here is 2,000 because it's given to us that 2,000 is the standard deviation in this specific problem. Okay? Now, the distance from here to 2 standard deviations would be 4,000. Okay? So let's take these examples. Let's take the example of this one right here. So I can find how far away this number is. I can find out how far away this is, how many standard deviations this is from the mean by first I can take the distance away from it. So I take 34,000 and I subtract 30,000, which is the mean. So what I'm doing, again, I'm finding the distance from here to here. The distance from the mean to my standard deviation is I take the data value and I subtract the mean from it. Okay, now by doing that, that gives me 4,000, right? That is my distance, like I said before. Okay, but that doesn't give me how many standard deviations away from the mean it is. So what I need to do is I divide this by how much a standard deviation is worth. So it's like converting it. So I know that a standard deviation is worth 2,000, right? Okay, so if I divide this by my standard deviation, 4,000 divided by 2,000 is 2. Okay, which is exactly how many standard deviations this is from the mean, right? So I know that 34,000 is 2 standard deviations away from the mean. Now, what I just did here can be generalized. What I did in this process is I took a data value. I'm going to call this data value x. X represents a data value. I subtracted the mean from it. And I did that because this tells me the distance away from it. But it doesn't tell me how many standard deviations away from it. But then what I did is I divided it by the standard deviation of the set here, of the problem here, and that told me how many standard deviations that was from it. I'm going to call this z. Okay, now this right here, this is something that you're going to want to highlight. This is what we're going to be using all throughout this unit, this section right here. This right here, this equation is so important. This is how we standardize scores. And why this is important, see, like for a problem like this, it's very easy to tell that 34,000 is 2 standard deviations away from the mean, because we're given that the standard deviation is 2,000, which means I just have to add 2,000 and add 2,000. So I went over 2 standard deviations. That being said, this is my question for the day. What if we want to find the area under the curve, but for a standard deviation between 1, 2, and 3? So for example, now these were very simple problems. What if I asked you to find the standard deviation for 31,000 miles on this a tire that was 31,000, and I asked you to find the area under the curve for this? Okay, so right here what if I asked you to find the area under the curve for this right here? Now, we don't have an empirical rule. There's no empirical rule that tells you how much this is. But what I could do is I can convert this and standardize this into a standard normal curve. So I could take 31,000 and I can find the distance between 31,000 and the mean. So then I can subtract it from 30,000 and divide it by my standard deviation. Okay? So when I do that, I get 31,000 minus 30,000, which is going to be 1,000, divided by 2,000. Now this is going to be equal to 1/2, meaning that this is 1/2 standard deviation. So this is a half standard deviation away from the mean. Okay? Again, so that's the idea about standardized normal, is that what if we have a data value that isn't exactly 1, 2, or 3 standard deviations away from our mean? Okay? That's the point of standardization, is that it helps us standardize everything so that we can find the probability. Okay? So right here, this is the standard normal curve. So this right here is the standard normal curve. Always note that a standard normal curve, 1, the mean is always equal to 0. 2, the standard deviation is always equal to 1. So in a standard normal curve, we always identify the mean as 0 and the standard deviation as 1. Now, in the left direction, we use -1, -2, and -3. So if you have a negative standard deviation or a negative score, that means you're to the left of the distribution. Okay, so this is what we're going to be doing today. Now, I'm going to bring this back up over here. A z-score is this right here. Z is equal to x minus mean over the standard deviation. This is a z-score. And a z-score tells you, or I'm not gonna say tells you, I'm just gonna say the z-score is the number of deviations, of standard deviations away from the mean. Okay, now again, so what that means is if I give you like a number like 27, okay, so this would be, that's 30, so that's going to be 20. So let's say I give you like 27,564 kilometers on a tire, okay, and you want to find what percentage that is under the curve. Now, you can't tell me how, like 27,564, how many standard deviations is that away? We don't know that unless we convert it to a z-score. Now it's easy right here because 32,000, that's one standard deviation, but it's hard whenever you have such a specific number like this, okay? So, but with a z-score, we can find how many standard deviations away from the mean it does lie, okay? Now this is just a duplicate, it's redundant, don't really need this curve there, but this right here is your standard normal curve. Okay. Now, I haven't told you how to calculate probability just yet. Okay, so for example, if I found that a data point was, let's say, 0.67, negative 0.67 standard deviations away, and I want to find the area under the curve right here, but for a standard deviation of negative 0.67. We still don't know how to calculate this area. Okay. So this is where we use z-score, a z-score table. Okay. Now you should be able to print a z-score table off online. I'll probably post it on Canvas. In fact, right now I should probably go ahead and find one for us. So a z-score table, and I'm going to specifically ask for a PDF. So if you're looking for one, You can just do z-score table PDF and you should just be able to find one. Okay, perfect. This will do good for me. Okay, so this is what a z-score table is. And I'll show you how we can use it in the examples. But a z-score table tells us, so if I calculate on the left hand side, it tells you, so if I right here, so I'm trying to find the area under the curve at negative 0.67. So if I go to this z-score table, I'm looking for negative 0.67. So on the left hand side, notice that towards the bottom, so right here I can see negative 0.6. Okay, that's negative 0.6. And then on this top row it tells you 2 decimal places over. Okay, so I'm trying to calculate the z-score. So 0.7 is over here. So in this column right here, I'm going to match it up with negative 0.6. Okay, so negative 0.6 is right there and right there. So you see 0.2514. This is the area under the curve at the z-score of negative 0.67. So 25.4%. So right here, this is 25.14% of the curve. Okay, this is what a z-score is. So it tells me that at the point negative, at the z-score, so if there is an item, if there is a data mark that is negative 0.67 standard deviations away from the mean, then the area under the curve is 25.14%. Okay, now again, this is kind of the equivalency to using the empirical rule, but the empirical rule is pretty much set, and that empirical rule still applies here, but for finding the area under the curve in between our standard deviations, we're going to use the z-score. Okay, so we're going to use this z-score a lot today. Okay, and then that's how you calculate probability. Okay, now this is going to be a little bit different today for calculating probability, because before all we had to do was count up these percentages. So if we were within 2 standard deviations to the left, we could just add those up, right? We're going to be doing it a little bit differently today. Okay, so right here, to calculate probability, let's say this is the mean right here. And then we have, so the mean in a standard normal curve is 0, and then 1, 2, 3, negative 1, negative 2, and negative 3. Okay, so whenever I want to calculate probability for a single data point, it depends on what it's asking for. So let's say that it's asking you to find the probability that an item is less than negative 1.5 standard deviations away from the mean. So all I have to do is find the z-score for negative 1.5. So I come here, look up negative 1.5, and that tells me the percentage, the probability that it's going to be under that part of the curve. If it's asking for more, so let's say that it wants to know the data, or it wants to know the probability that a data value will lie somewhere greater than negative 1.5 standard deviations. So I'm trying to find the area right here. So if this is the case, then what I'm going to do is I'm going to take 1, which is the total area under the curve, but then I'm going to subtract this right here. So I'm subtracting this right here. So then I'm going to do 1 subtract whatever the probability is of this section right here in order to find the probability in the red section right there. And then there's the matter of finding the probability between 2 data sets. So if I wanted to find the probability, let's say between right here, if I'm looking to find the probability between these 2 data sets, in order to do this, I first have to calculate the data for this entire first portion right here. So I find the probability for this z-score right here, but then I have to subtract the probability from this z-score. So I have to subtract away the probability here. Okay, so I think it will be more clear when we get into our examples. Okay, so that will lead me into the assignment for this unit right here. So It says that the scores on a test administered to prospective employees are normally distributed with a mean of 100 and a standard deviation of 12.3. Okay, so if we were to draw a normal distribution, okay, this is something that we did a lot last time, then we'd have the mean of 100 and a standard deviation of 12.3. So this would be 112.3, okay? So on and so forth. But here's the thing. Now, it's asking us first in this problem, it wants to know the percentage of scores that are between 70 and 80%. 70 and 80, or not 70 and 80, the scores between 70 and 80. The scores of 70 and 80 do not lie upon exactly 1, 2, or 3 standard deviations away from the mean. Okay, so that means we have to standardize it. We have to transform it. Okay, so 70 and 80 are going to be somewhere over here. We'll call this 70. We'll call this 80. Okay, so this will be 70. This will be 80. Again, we don't know how many standard deviations away from the mean that these are exactly. So we have to find out how far away these are from the mean. Okay, so I'm first going to find out how far the score of 80 is from the mean. And I'm going to use my z-score. So the z-score says that z is equal to your data value, subtract the mean, divided by the standard deviation. Okay, so this right here is my data value, so in this case 80. So I'm going to take 80, I'm going to subtract the mean, which was 100. And I'm going to divide by the standard deviation, which is 12.3. Okay, so 80 minus 100 divided by 12.3. So 80 minus 100, that divided by 12.3 is negative 1.6, and I'm going to round up to negative 1.63. So this is equal to negative 1.63. This is my z-score for 80. So basically what this tells me, so I'm going to draw a normal standard curve, a standard normal curve. So the mean is always going to be 0. So in this case, 0 represents my 100 mark. Now, negative 1.3, so over here, negative 1.63 represents my 80 mark. That's my 80 mark. So now I want to find my 70 mark, because I'm trying to find the area between these two. So now I have to standardize 70. So I do 70 minus 100, so the data value minus the mean, divided by the standard deviation. So I do 70, subtract 100, divide that by 12.3, and I get negative 2.44. Negative 2.44. So I know that 70 is negative 2.44 standard deviations away from the mean, which is 0. Okay. Now I am trying to find the area right here. I'm trying to find this area right here. Now there's no empirical rule for negative 1.63 standard deviations and negative 2.44 standard deviations. So what I need to do, I first need to find the area for everything less than negative 1.63. So let me do that here. I'm going to use my z-score table, and I'm going to find the area under the curve for negative 1.63. So let's go to my table here. So negative 1.6, so there's negative 1.6 right there. But then for this 2 decimal places over, that's going to be in this column. So 0.0516. 0.0516, or in other words, in a percentage, that would be 5.16%. Okay, so that 5.16% represents the area under the curve for this much right here, 5.16%. But I'm not interested in that. I'm interested right here, the area under the curve right here. So what I have to do now is I have to subtract away this area right here. And this area right here is the area under the curve at negative 2.44. So let's find the area under the curve for negative 2.44. So negative 2.4 is right here, and then go over to 4. So that is 0.0073. So the area is 0.007, I said 73. Or in other words, in a percentage, that's going to be 0.73%. So not much, right? Okay, so now what I'm going to do is I'm going to subtract these probabilities. So I'm going to take 5.16% and I'm going to subtract 0.73%. So 5.16 subtract 0.73, and I get 4.43%. So this is equal to 4.43%. So that is the area under the curve right here. So while this is 5.16, this was 0.73%, which gives me the area here as 4.43%. Okay? So about what percentage of scores is between 70 and 80? 4.43% of scores are between 70 and 80. Okay? So I know it takes a long time to explain that, but the more you do this, the faster you're going to get at these problems. I promise. The more you do them, the faster you're going to get. Okay. So how about you try converting these scores right here? So for B, about what percent of scores are between 85 and 115? Okay. So if you're going to set up a standard normal curve, this is 0, the mean, which is 100, right? It's represented by 100. I'm trying to find scores between 115, so I know that's greater than 100. So this right here is 115, and then 85. So 85 is over here. Now you need to find the z-scores for both of these, okay? Because you're going to find the z-score for 115. So to find the z-score for that, you're going to do 115, subtract the mean, divided by the standard deviation. Okay, and then you're going to do the same thing for 85. You're going to take 85, subtract the mean, divided by the standard deviation. So then you're going to find the z-scores. You're going to use those z-scores, look up the z-table, and find the area under the curve. So first you're going to find the area under the curve for the greater value. You're going to find the area under the curve right here. And then you're going to find the area under the curve for the lesser value, and you're going to subtract that value away from it. And that's how you're going to get the value in between them. Okay, now for this one, it's asking what percent of scores are over 115. Okay, so this is one that I want to cover. So it looks like we're going to need to find this value out anyway. So when it's asking for the percentage over, so let's take our standard normal curve with a 0, and then right here, this is the data for 115, so we're going to find the z-score, but we're trying to find the percentage of scores that are over 115, so I'm trying to find this tail end right here. Okay, so let's find the z-score first for 115. So 115 subtract 100 divided by 12.3. So 115 minus 100 divided by 12.3, so I get 1.22. So that's my z-score, 1.22 standard deviations away. Now let's find, so here's the thing though, whenever I look up the z-score, you look at this right here, it's only telling you the probability to the left. It's not telling you the probability to the right of your z-score. Okay? Now we're trying to find the probability to the right. So whenever I find this probability in the z-score table, This is going to tell me the probability to the left of that. Okay, so let's find it out. Okay, let's go ahead and look up that z-score. So 1.22. So this is going to give me a percentage of, so we're going to go on to this page. Notice that this page is for negative z-values and this is for positive. So 1.2 is right there. 1.22 would be right here at 0.8888. So is 0.8888 or 88.88%. Okay, that's this right here. That's this area. This area right here is 88.88%. Okay, now I'm not interested in that area. I'm interested in this area. So I know that the total area under the curve is 1. So if I take 1, and what I want to do is I want to subtract away this area right here away from 1 in order to get my area in the green. So I need to take 1 and subtract 88.88 from it. So 1 minus 88.88. Sorry, if I'm doing a decimal, I'm going to do 1 minus 0.8888. And I'm going to get 0.1112. So equal to 0.1112 or 11.12%. So that is the percentage of scores over 115 right there. So that's how you find probability greater than a z-value. You have to take 1 and subtract away the area to the left. Okay. Okay. Now for something like f, if so for these, both of these ones right here, so these are pretty similar to what we did last time. So let's do f. It's pretty similar to e. So in f it says if 75 people take the test, how many would you expect to score lower than 75? So I need to find the percentage that score less than 75 first. So in a standard normal curve for this data set, this is 0 or 100, right? Now 75 is to the left of this, okay? So this is going to be 75, but let's find the z-score for that. So 75 minus 100 divided by 12.5. Now I know that 75 minus 100 is negative 25, so divided by 12.5. But anyway, so 75 minus 100 divided by 12.3, and I get negative 2.03. That should be 3. Negative 2.03. So that's my z-score. Negative 2.03. Okay, and I want to find how many people are expected to score lower than that. Okay, so let's find the area under the curve for the z-score of negative 2.03. So negative 2.03. So negative 2.0 is right there, and then 3 would be right here. So that is 0.0212. So 0.0212 or 2.12%. So that is the percentage of people expected to score lower than 75 on the test. But if 75 people take it, what I want to do is take 75 people and multiply that by 0.0212. Whoops. So take 0.0212, multiply that by 75 people. Did I do that right? 75. Yeah. Okay, so 0.2, so 2%, so 2.12% of 75 is about 1.59. So I'm just going to round up. So this is equal to, not an estimate, this is equal to 1.59. But I'm trying to find people, so that doesn't really help me if it's a decimal. So I'm just going to round up and say about 2 people would be expected to score lower than a 75 on this test that employees took. Okay. Again, it's a lot of explanation. I'm sure you guys are tired of listening to this. But the more you practice it, the easier the more sense that it will make. Okay. Let's see if there's anything else that might be worth talking about here, because all these should follow pretty much the same process. Okay. But let's talk about number 4, because the wording can be a little bit tricky. Okay. So number 4, it says the daily July surface temperature on a lake at a resort has a mean of 82 degrees. So that's the surface temperature of the lake in July, the daily July surface temperature, and a standard deviation of 4.2. If you prefer to swim when the temperature is at least 80 degrees, about what percent of the days does the temperature meet your preference? Okay, so the wording is really tricky here. But let's go ahead and draw a standard normal curve. So if I draw a standard normal curve, so the daily July surface temperature of a lake at a resort has a mean of 82 degrees and a standard deviation of 4.2. Okay. Now, if you prefer to swim when the temperature is at least 80 degrees, about what percent of the days has the temperature? So I want to find 80 degrees. Now, I know that the mean 0 is at 82, so this is at 82 on a normal curve, but 0 on the standard normal curve. Okay, now I'm trying to find 80, which should just be right here. So I'm just going to find where the z-score for 80. So I'm going to do 80, subtract the mean, divide by the standard deviation. So 80, subtract the mean, divided by 4.2, which is the standard deviation, and I get negative 0.48. So 80 degrees is negative 0.4 standard deviations away from the mean. Now, here's the thing though, okay? So it says at least 80 degrees. So what a lot of students are going to think is that, oh, let's find the area under the curve here, and that will cover what I want to find, right? The area under the curve, that's what I'm looking for. But the key word here is at least. So I want to find anything greater than 80, okay? So this wording right here, it's really meant to try and get you to think less than. But at least means I want it to be warmer than 82 degrees. So I'm really trying to find this area right here. So you're going to have to do 1 subtract the probability of the curve, of the area under the curve, for this z-score right there. So it's kind of like the same thing as up here for scores that are over. So pretty much like right here, what about percentage of scores that are over 115? Another way of saying this is what about what percentage of scores are at least 115, okay? So at least is just another way of saying more than, right? Okay, so don't get confused on that wording right there. Now let's talk about number 7. This should finish up our lesson, okay? So in number 7, you're going to be working backwards, okay? And this can be a little tricky. So it says the Welcher Adult Intelligence Test Scale is composed of a number of subtests. On one subtest, the raw scores have a mean of 35 and a standard deviation of 6. Assuming these raw scores form a normal distribution, what represents the 65 percentile? So what number separates the lower 65% from the distribution, okay? So we're not trying to find a z-score per se here. So if I have a standard normal distribution, okay, the 65%, well, I know that this is 50% right here. But let's say, so this is 65% right here. Let's call this 65%. So the area under here is 65%. So the area under here is 65%. Now, what I'm interested right now is I want to know the z-score that represents 65%. So what is this z-score right here? Now, the thing is, I'm not given a score here to help me find that, but I am given the probability, 65%. So I can go back to my z-score table right here. I want to find, so again, this middle section in this table tells us the percentage under the curve, right? So if I want to find 65%, I'm looking for 0.65 or what's closest to that, okay? So notice here that again when z is 0, that's at the mean. Notice that the area under the curve will be 0.5 or 50%, but I'm looking for 65. So let's go through this table. Okay, so I'm getting closer right here. So you notice here that I have 0.648 and 0.6517. Okay, now neither of them are exactly 0.65, right? But I know that 0.6480 is 0.002 away, and then this is the other one's the I believe that the one on the right is closer to it, so I'm just going to use that one. Okay, so that's under the column 0.09. Okay, and this is in the row. If I follow this row all the way to the left, that's 0.3. So 0.39 gives me the area of about 0.65. So 0.39 would be my z-score right here. So this z-score is this z-score is 0.39, about, roughly. Okay, so now I'm trying to find the number that represents the 65 percentile in terms of this. So basically what I'm trying to find, if I had just the normal distribution, okay, normal distribution, again with the mean of 35 and a standard deviation of 6, I'm trying to find where this lies on here. So what would be the actual score, not the standard normal score, okay? So what I need to do is I need to work backwards. So I'm going to use the z-score equation, but this is what I'm trying to solve for. I'm trying to find this data set, okay? So x minus the mean over standard deviation is equal to the z-score. Now I now know what my z-score is for the 65 percentile. Okay, so I can write this as 65, or sorry, not 65, I can write that as 0.39. This is my z-score. Z is equal to that. Okay, so I can replace this with 0.39. Okay, I know that the standard deviation is 6. I know that the mean is 35, and I'm trying to find my x value right here. So I'm going to solve for x right here. So to do that, I'm going to take 0.39, multiply it by 6. So 0.39 multiplied by 6, 2.34, and then I'm going to add 35. So plus 35, and I get 37.34. So x should equal 34. So this right here, this test score represents the 65 percentile mark on the normal distribution. Okay. So when it's talking about percentile, you have to work backwards. You have to find the percentage under the curve. You have to use your z-score table to find the z-score for that percentage, and then use this equation right here, but instead of solving for z, you're solving for x because you have z. Okay, so you can do the same thing for b right here, and then the rest of this should be pretty normal from what we've been doing before. Okay, now I know that this was quite a bit of information, but it should be easier just by doing this practice worksheet. There's a lot of practice problems here, and if you do them all, if you try, you give it a go, ask me questions, come to me whenever you need help, I promise at the end it should make sense, okay? So just make sure to reach out for help when you need it, okay? All right, thanks guys.